Hi everyone, welcome back. Naji here. In this video, we will be discussing on subagents, and we will discuss a minimum theory, and I will show you that how can you write a code using subagents, and how can we integrate that with the deep agents. Okay, so let's start. As I mentioned in my last videos, the main agent will identify the complex task, and the task will be assigned to subagents. Then subagent will execute that, and the final result sent back to the main agent. Okay. So the main problem that we are trying to achieve is that the context bloat. So which means consider a scenario where the main agent is executing the everything. Okay. So for example, there is a complex task is there, or consider there are multiple complex tasks is there, and we have only the main agent, and main agent will executing this complex task. So it has to plan it, and it has to track it, and it has to remember all the intermediate step, right? So if you execute like one or two complex tasks, then it will eventually reach the context limit, right? So once it is reach the context limit, then it will start hallucinating, and it will produce the poor result. Okay. So to avoid this, what the architecture does is, or deep agent architecture does is, so the main agent will identify the complex task. The complex task will be assigned to the subagents, and subagent will execute that. So all the planning and the tracking, all everything will be done by the subagent, and subagent will return only the final result back to the main agent. So in that way, we will have some control over this context issue. Okay. Okay, this is what I have just explained. So we will have a main agent. Main agent will delegate to the sub agent, and only the summarized final result will be sent back to the main agent. Okay, so this is slide says about like when to delegate to sub agent and when not to. Okay, so already discussed that we will delegate to sub agent when we have a multi-step reasoning task, two heavy operations, data heavy processing, highly specialized domains, long running executions. So we will not use the sub agents. Like if it is a very simple, direct, and small tools, then the main agent will execute itself. Okay, the same thing in a different way. So there are two categories of subagents is there. One is the general purpose subagent, and other is the specialized subagent. So general purpose subagent is automatically added to the deep agent when it is initialized. Okay, and it has a by default it will do some basic research or the file system operations. Okay, so consider a scenario. Consider a scenario. I have a main agent is there, and I have a tool called NLP to SQL tool is there. Okay, I have not declared or not defined any subagents. I have a main agent with a tool. Okay. So the what main agent does is, okay, so it will go through the question or the request from the user, and it will find that okay, it has to execute the NLP to SQL task, and the LLM knows that okay, it is little complex task. Okay. So in that case, what it does is it will automatically trigger the general purpose subagent, and the general purpose subagent will trigger or will use this NLP to SQL tool, and it will execute that. So all the subagents have some access to the its prompt and the tools of its parent agent. So the general purpose subagent will able to access the tools, and it will execute, and it will send the result back to the main agent. Okay. So when we come to the specialized subagent, it is a defined, it's a custom built-in subagents. Okay, so like we can say that okay, I will write some subagent to search some specific scenario, and I can attach that with the main agents. Okay, then one important thing that we have to understand is the task tool. Okay, the task tool is also assigned to deep agents when we initialize it automatically. We don't need to anything. So the goal of this task tool is that whenever a main agent want to execute some subagents, it will trigger the task with its object, and then the task will execute the subagents. Okay, so we have to understand this, because whenever we write some code, then we may have to use the task tool. So this is the entire life cycle. So what happens is that the main agent access the complexity and send the objective via task. The subagents initialize and its independent reasoning loop. Then subagent executes specialized tools internally. Then the fourth step, intermediate chatter, errors, and the tool output hit the quarantine wall. It will not come outside. Then subagents return a single clean final result to the main agent. Okay, so that is the entire life cycle. Then there are two ways that we can initialize the subagent. One is the dictionary way. Okay, so which means I can define a dictionary like name, description, and system prompt, and this I can attach to the DeepAgents. So that is one way of doing this. And another way of doing is that I can use the compiled subagents. Okay, for example, I can use the create agent of LangGraph or LangChain, then I can attach that with the DeepAgents. So we will use this compiled subagents like for like a complex. Um, if the task is complex, we will use it is recommended to use the compiled subagents. Okay. So that is overall about the subagents. Now we can see how can we implement the subagents in both ways, like dictionary way and also the compiled way. Okay. For that, I already have the Visual Studio Code and I have my sample code is available. Okay. So here we can see, if you look on this project.toml file, we can see that I have a DDGS and I have a DuckDuckGo search is there, LangChain community is there, a LangChain OpenAI and Python .env and also DeepAgent is here. These are the major packages. Okay. So in this notebook, I'm importing few things. I'm importing the OS, I'm importing the literals, and here we can see I have a DeepAgents. Okay, from the DeepAgents, I am importing the create DeepAgent, and from the community tool, I am importing the DuckDuckGo search run. So this is using for the search. Here I am initializing the search. Okay, and I'm just trying to run that to see like this is working or not. Okay, so I'm telling that give me the latest update of LangChain. So let's execute it. Okay, so here we can see it is giving me some output. Okay, so I'm not going to verify this, but we are getting some output using the DuckDuckGo search. Now I'm defining a tool to do the internet search. Okay, then we will have a query is passed by LLM or agent. Then I am executing the search.run. I am passing the result, and this will return the result back to the agent. Okay, let's execute it. Okay, the tool is defined. Now I'm going to define a subagent. So as I mentioned in my the presentation, it's a dictionary based subagent that we are going to define. Here we have a name, description is there, system prompt is there, and I'm mentioning the tool. So here this is the tool we are going to use. Then model, I'm going to use the GPT 4o. Sorry, 5.4. Now let's execute. Then I'm making it list. Okay. Now we are going to initialize the DeepAgent. So here we can see DeepAgent. I'm passing the system prompt, model, and the subagent. Okay. The subagent is the research agent here. Now let's execute it. Okay. Now I'm going to run, or I already run that. I am going to trigger agent.invoke. Here I'm defining, or I am passing the user content. So I'm asking about compare 2024 financial profit among Meta, Microsoft, and Google. Okay, the spelling is not correct. Anyway, let's see. So this is the question that I have asked. So we'll see the result. Okay. So if you look on this create DeepAgent system prompt, we can see that I'm specifically says about you are an agent and you have to use subagent to get the result. Never use your own knowledge base. So you should trigger the subagent, because I mentioned that clearly, explicitly mentioned that you should not use your own knowledge base. Okay, let's see. Its execution may take some time, and before that, I will explain the compiled subagent code also. Okay, so here what I'm doing here from the DeepAgents, I'm importing the compiled subagents, and from LangChain.agent, I'm importing the create agent. Okay, so using this create agent, we are defining an agent. Okay, so here I'm using GPT-4o model, and the tool I am using the internet search, and this is the system prompt. So earlier we have used the dictionary for this one, right? Here we are using the compiled way. For that, first we will create the agent, then we will encapsulate it with the compiled subagent. Here the name is search, and I am passing a description, and runnable, I am assigning runnable as the custom search. Okay. Now once we have the compiled agent, I can put into, like in a similar way, I can put into as a list, and this list can be passed to the create DeepAgent. So if you look on here, we can see that I'm defining the create DeepAgent. Same system prompt I'm using. The model is GPT 5.4 and I'm passing the latest subagent. Okay. So this is the code for the compile subagent. Now we can see the result of the dictionary. It is still running. Ideally, it should be complete by a minute or so. Maybe I will stop it. We'll wait for a couple more seconds. Okay, so I will stop it and we'll see the result. So the execution is completed. You guys can see execution is completed in 23 seconds. Now let me print it. Okay, let me print the result. Okay, so this is the result. Now let me extract the last message only. Let me take the last message and print it. Let me print it. Okay, so here we can see the result and 2024 profit of the Google, Microsoft, and Meta can be seen here. And they have made some ranking also, and they're providing some note. Okay. Now, in a similar way, let me execute the other way also, the compiled subagent. So let me execute this. I'm initializing the create agent. And this is the agent, subagent. Now, this is the compiled agent, and we are making it a list and just passing it to the DeepAgents. Executing it again, the result one. This also may take maybe some seconds, I believe. Let's see. Okay. So the execution is progress. The prompt, the same prompt I have copied. Okay, here we can see compare the financial profit of Meta, Microsoft, and Google. Let's see. Okay, I believe it's taking some time. Let me stop and we can start it. Okay, the execution is completed now. Now let me print the result. Okay. So here we can see the result. Maybe some, let me see the results are same or not. Okay, this result are like almost same. So we are getting a little bit more detailed way. That is maybe only because of it's a prompt. Yeah. So that is all about in this video. So I believe this is clear. Like I have explained about like how can we do with the dictionary way and how can we create a subagent using the compiled way. Okay. So I will upload this into my GitHub repository. You guys can download and try it out. So that's it. Please do like and subscribe. Have a nice day. Bye bye.